Thank you. Sergey, would
Uh,
you start?
yeah,
Sure.
of course. Hello, everyone, and we'll present results of our work. And before it, a little bit disclaimer. So we have a small team in our lab, and we dedicated to studying some cognitive effects on programming. And actually, the idea of every of our research is try to find the cognitive effects from classical cognitive psychology outside the laboratory, and especially in terms of in context of classical programming or real work environment. And previously we presented our work when we tried to replicate uh, how to overcome the mental set effect. Yeah, and now here is our second work, and here we try to understand and try to catch how actually perceptual load works on performance while people coding in IDE. So yeah, spoiler. Here results a little bit more positive, and we'll have something to talk actually about. However, the important part here is that we try to base everything on solid academic cognitive work, and probably Agnia will talk more about it. So, Mick to you, Agnia, and
Thank you.
let's start.
Okay, so yeah, we are talking today about how people with ADHD, sorry, symptoms interact with IDE, and how can we help them to do that more efficiently. Here we should talk about definitions a bit. First of all, thing is neurodiversity. Yes, the first term will be neurodiversity. It is the state of our body. It's alterations of mental function, which is caused by development of our neurons in some different way. Yes, so it is diverse from neuronormal, and people who has this condition they have different they can be marked with different like diseases. Yes, they can be people who are neurodiverse can be people from autistic spectrum. They can be people with dyslexia, and they can be people with attention deficit hyperactivity disorder. It is the disorder, and it is our second term. I guess I will use ADHD symptoms. Yes, shorten one. So it is the disease, the state of our mental functioning when self-regulation abilities are impaired in a way. And also here in our work, the term of perceptual load is important. Perceptual load is the amount of information involved in processing of stimuli. It may be perceptual load, may be visual, maybe audio or ATC. We are talking in our work about visual perceptual load. So the amount of information person sees, just simple as that. So the pain. This study and our previous study, they both are dedicated to help people in a way. First one was about helping students code more efficiently, and here we are in more inclusive contexts. We are here trying to help people with symptoms of attention difficulties cope better with their work. So to help people, neurodiverse people, help adapt in their work environment better. So that is the main our goal, yeah. And the pain of people with ADHD, maybe problems with self-regulation in different circumstances, with time management, with problem solving, with self-discipline, motivation, and activation, self-concentration. This division into 5 components, it's not just from our heads, it is the common nowadays division from Berkeley. We will talk about this a bit later, about his theory about ADHD. Sorry. You can count numbers of variations of that abbreviation I use here today. Nowadays, in theory of this disease, people think that self-regulation of neurodiverse people can affect some problems in real world, and they have to, not have to, but people with that symptoms may need some accommodation, and our work is about that accommodation. In previous research, of course, some research was done, were done before us. It was shown that people with symptoms of attention disorders, they better concentrate on tasks when the environment is noisy. What does it mean? It means that, let me show the picture here. It means that with tasks where SpongeBob with B screenshot, which is lettered by B, people with ADHD, they cope better. They found N letter faster than in circumstances of on the screenshot, which is lettered with A, on low perceptual load. So we thought about how could we use that information in our work in context of IDE, and we hypothesized that for programming tasks of different attention levels, perceptual load will affect the solution's efficacy, and the effect of perceptual load might be differ for people with or without or with different types of impairment of the attention. So here we think about people with ADHD as not about people with the disease itself, but as people with symptoms of it. So, and people who has such symptoms, they struggle a lot with monotonic tasks. So that is why we used 2 levels of attention activeness. Let's talk about that more specifically. So we used more monotonic, like debugging task, and we used more attentionally active, mentally active task as coding, like writing programming function, and that is how we operationalization. Sorry, I wrote that word, but I didn't thought that I would tell it out loud. So that is the problem. That is what we mean when we say programming tasks of different levels of attentional activeness, debugging or coding. Debugging is more monotonous. I think you all know it is like very hard to concentrate on task, especially if it is long enough. And coding as writing, just more active, mentally active task. Here it is first point of what we mean in our hypothesis. The second is perceptual load. We already talked that perceptual load is how much information do you see in this specific case in front of you. So perceptual load in our research was the number of panels in IDE, and low perceptual loaded has 1 visible panel, like logically united block, and high has 7. Let me show you, it would be better. This is Zen mode. This is low perceptual mode. So we have only one block of information here. Maybe two if you will be more specific. Yes, here. So this is low perceptual mode, and this is debugging, and this is just the beginning of the, as you see by scrolling bar, it is just the beginning of our task. It was really long, like it took about 15 minutes. Maiden was something like that, I guess. And this is white boxes is just for confidentiality. This is high perceptual mode. So you see the difference. Yes, it has lots of comparatively lots of information. And as you see, this is a code writing task where we provided some mathematical formula and asked to transform it into Python language. So translate. Yeah, so here what we mean under perceptual load of different levels: high level, low level, and high level. Here, some words about solution efficacy. Solution efficacy in our in context of coding or writing, like programming, it may be lots of different things, and it may depend on task. And we decided to use here as the solution efficacy measures in coding overall time, as you see, average time for one line of code for each of them, the overall coding speed, so how many symbols per second is written, and the number of edits made. So the person writes the code and then edit it. And in debugging, we have somewhat different solution efficacy measures. Of course, overall time taken, and number of changes, number of fixed bugs, number of user actions. And here, I think the best would be for Serheyuk to tell about the measures and about. Do you want that?
Yeah, just a moment. So yeah, here's the next slide is probably about architecture. Yes.
No.
No. All right. So we'll later I'll say a few words about architecture and design of plugin. However, here I wanted to notice about these tasks. Actually, we come up with a little bit simplified tasks and measurements. However, we need to solve it automatically because we could not do code review for each solution or each debugging session. So yeah, it was the best measurements that we could derive from the data which is given from the IDE itself. So we have the stream of edits from each person, and we just constructed this metrics from the stream. Yeah, there was a few more. However, they did not end up in analysis because of different problems with analysis and with different problems with noises. However, this was the final result of metrics.
Yeah, thank you. So this is the list of our measures we used in our research, yes. And the impaired executive functions here is, I guess, the main ADHD part. What does it mean? In the theory of this disease, people now are thinking that some impairments of these executive functions may be more or less contribute more or less in every instance of the disease itself. So people may have different variety of severity of impairment of these measures, but still have ADHD. So we measured the level of impairment by Barkley Deficit and Executive Function Scale. It is a widely used scale nowadays in diagnosing of the mental state of people with ADHD. So we use that, but we use that on assumingly healthy people. So that is the way we avoided like law restrictions, and the way we still have some people who has impairments in their life, and that helped us to gather the sample in our circumstances.
Here is also a small comment, maybe on two main reasons why we did not use actually people who are diagnosed with attention disorders. So the first reason, as already Agnia told, that it's legal reasons. It's much harder to operate with the data of medical diagnosis, and we just didn't want to work with this. However, the second problem is much more serious. In the preliminary part of our study, we tried to estimate actually how much people who know how to code and have diagnosed attention disorder, and we found something around 3 people. So, and here's the main problem, that it's rare when people are diagnosed with these disorders in the later parts of their life, when they're actually proficient programming. However, this does not mean that these people have no such disorders, because that it's just kind of a not new, but disease who is frequently diagnosed. This disease frequently diagnosed in the young years, and if this part was skipped and nobody put a person to the doctor, so it will be never diagnosed. So we believe that we're still working with a quite representative sample.
Yes, that's right. Thank you for that addition, because really people with this condition, they adapt during the life, and they may not be sufficient to have a diagnosis in their later years, but they still will be having some problems with executive functions. So that's what we measured in our research. Yeah, here about our research. Overall, we had 35 participants, and it is a win, because usually people not eager to participate in long experiments, as our was like 1 hour sitting in front of the computer doing not work, but still we have a lot of people who were interested, and we are thankful for everybody and each of them, and we are hoping that in our future works we will be able to gain more, but 35 was enough. All of them had the scale, which they received through the plugin. We will talk about it in just a moment. So people received the email with instruction how they install plugin in their PyCharm. We used PyCharm. In that PyCharm, plugin showed them the scale, which measured their level of severity of their symptoms. And then they had 2 sets of tasks. First set was combined with is presented by combination of debugging and coding, and as you see with errors, it may be interchanged, because we wanted to balance the the effect of sequence and to see the median of how to say
Yeah,
that,
so
to
we
eliminate the
randomized,
effect.
yeah, we
Okay.
randomized order in order to avoid any learning possibilities. So that in order to avoid that, firstly, people were eager to solve the task, and later they will be tired. So all tasks
Yeah.
was randomized inside the group and outside of the groups. So should be no effects of learning or tiredness and so on.
Yeah, they are just eliminated through that principle of this equation. Yeah, and so two sets. In each of them was debugging and coding, and one of them was on high perceptual load, and the other was on low perceptual mode. And after a person solved all four tasks, they had a feedback about their answers on the scale, and we also gained some feedback from them about how they cope with that symptoms if they have any, and about how they felt about uh, this experiment. So we gained like post-experimental interview. We did that. And all of that couldn't be happen without the plugging. So here's Siroja. Yes, I would like to give you the mic.
Yeah, so just a few words about plugins. So we'll not dig deep in the technical realization. However, first of all, here on the seminar, actually, we have Vyacheslav, who developed it. So you have any questions about its realization, you can ask him. And special thanks from me, because it was quite a lot of work to develop this thing. So yeah, we developed plugin based on previous work in our lab. So there was study about task tracker, and we upgraded it, and it allowed us to present people with questionnaire. So our skills, you can answer questionnaire in there, and it first of all provided the tasks, for example, coding and debugging tasks that we had, and it's also could change configuration of IDE in any state that we wanted. So with few panels, with no panels, in Zen mode, in no Zen mode, so any action is available, we can pre-configure it and experiment with it. So and also it collected and recorded all actions and collected all stream of edits that was made by user. So as a result, we can get a PyCharm in any state we wanted with given tasks and collect all data that is provided when people start to code. Yeah, and also an important thing about validity of our study, uh, because we wanted to achieve to monotonous task and hard task, we were we needed to cut some features of PyCharm, such as auto-completion and error inspection, because when you have debugging tasks, sometimes some tasks are so very well, some bugs are so very well highlighted that it's kind of a not very monotonous just to automatically fix all of this. Or just we have some bugs that are connected to the style guide, and you can just automatically fix the style guide from the IDE. So we switched off these functions just to test mental activity of participant. So this is one thing that is kind of deviates from typical typical IDE workflow in our study. Yeah.
Yeah.
And next,
So
yeah. Mhm. So sorry for the big white screen. Yeah, here we have architecture of our plugin. It's quite complicated thing. However, I wanted just to focus on one detail. Is that we have two separate parts. One is a plugin, and one is server for this. And actually, we designed this plugin in such way that it could be easily configured for any other tasks, any other questionnaires, and so on. And we want to continue this work So this plugin could be actually a tool to study such effects in IDE. So you can provide any questionnaire you want, you can provide any task you want, you can configure PyCharm in any way and collect the data, for example. So we tried it and it worked well for us. However, there are a few architectural bugs that we want to avoid in next iteration of this plugin. However, it's already could be used if you want as a tool for investigation of cognitive phenomena in programming. So, and it's open source. If you're interested, you can write to me or to Agnia.
Better
Yeah.
to Serежа.
Yeah, all right. And also we have additional analytical tool because raw data from the plugin is very hard to analyze, and we also have all post-processing pipelines have done, and it's also open source, and you can use it to simplify your analysis. Here's also special thanks to Vyacheslav and to Nastya, who is also here for all analysis have done. So you can see that we have quite big team to work on this project. Yeah. So and after everything is collected, let's talk about findings. Back to you, Agnia.
Yep. Thank you. Thank you. So the plugin was the star of the show, and it helped us gather and analyze information from people and do findings. Yes, let's talk about them. As you might remember, we hypothesized that perceptual load of the programming might affect a programming environment, so IDE, might affect the solution efficacy. So if, for example, yes, the difference in perceptual load might affect somehow the solution efficacy. To check that, we we took separately coding task and separately debugging task. And in coding task, we found that for first symbol time, so the time when a person first push the button on their keyboard, the faster it was made faster on low perceptual mode. That is logical, as I think. But for coding speed, it was faster on high perceptual mode, and this is the word why, because it is non-intuitive why people code faster when there is a lot of information to process in their visual on their screen. As we think about it, we think that habituation plays the role here. So if person used to work on screen with all of that panels, it would be faster and easier for him or her to code in their usual way. But when the mode is changed, when they code on the environment they are not used to it, if they are not used to it, they need some time to adapt to it somehow, yes, and to see how it works. And that's why maybe they start faster, but then maybe they somehow distract themselves or something like that. We are not 100% sure, and it might be an interesting research question for further researchers. But here we see the statistically significant difference in code speed in different perceptual load modes. Yeah, that is for coding task. And for debugging task, as we see, the overall debugging time was less for low perceptual mode. And that is also, I think, intuitive, logical, because when you distract less on debugging task, yes, you have only one page to focus on, you might be quicker in this task. That is why maybe we have such findings in here. That is what was about perceptual load effect on solution efficacy. The second question was the effect of symptoms presence and effect of it on the effect of perceptual load on people with different symptoms of ADHD, and no correlation was found. So no matter what perceptual load person work on, it doesn't matter for him or for her. There was no connection of solution efficacy in that case, but we did found the how to say it, combined effect on solution efficacy and symptoms of ADHD on solution efficacy. Yes, the perceptual load, and let me show you. So here we see that for coding task we did not find any effect, but here on debugging task, if a person has problems with time management, self-regulation of time management. So this is the symptom of ADHD. This person will benefit compared to high perceptual mode will benefit from switching on low perceptual mode. So as we see, if time management impairment is true, the first bug fixed, so the solution efficacy of the debugging task would be made faster. The first bug will be fixed faster in low perceptual mode than in high perceptual mode. So that is our main finding, in fact. The main finding is that if person has some kind of, in our case, symptom of time management problems, they might benefit in switching from switching to low perceptual mode, to high perceptual mode. Oh, shit. Yes? Let me review it once again. Yes, that's okay.
Yeah, it seems correct. Yeah.
Yeah. So if you have time management difficulties, try make your environment noisy, and that will help you to do your work better if it is monotonous. Yes, I hope. Yes,
Yeah.
I said everything right.
So
I just freaked out for a moment.
Yeah, I know, because this results a little bit counterintuitive. So I have few chats with, for example, our designers to develop a more minimal designs, and they told me that it's always better to have minimal design of interface. However, in this case, when you're doing something monotonous, it's good actually to have some kind of a noise in your interface or some additional information, because it's one of our hypotheses why it's happening, so that it's impossible for such people not to distract at all. So, and it's better to distract inside one interface, but in different parts of it, than just switch out from the IDE to something else and come back, because it's much harder. So some noise could be beneficial for people with some attention difficulties. And
yes, this is why that is happening, because people, when they have attention it is the theory of capacity. So in our attention, we have a capacity, for example, 7 items to focus on. And if this capacity is exhausted, we just have like 1 item to focus on. So if we already exhaust this capacity by our platform, we have nothing else to do except just focus on that task we are doing. So that is the theory lying under that effects.
Yeah, so yeah.
Like
Lastly,
task, like debugging task wasn't hard enough to consume all of your attention. So for people with attention difficulties, you need something else to consume your attention, to not to be distracted from your task.
Yep.
Yeah. Lastly, I wanted to say that, to be honest, it's not of all our results for this study. It's just selected and the most stable results and most significant one. However, we have also some correlations and some effects on lower levels of significance. However, we do not report them. However, they overall they make us believe that there's much more complex behavior underlying this. So yeah. Lastly, and in that, I wanted to special thanks to all the team who worked on this project, because it took a lot of people and it was quite complicated one. And special thanks to all people who participated, and in our lab, who actually a lot of people from our lab who helped me guide this project and helped with some comments and so on. So thank you everyone, and thank you for visiting the seminar.
Yeah, thank you very much.
We would be happy to answer any of your questions.
Yeah.
Yeah, thank you guys. So what's the like practical implication? I got it that it's like the overall idea is that complex interfaces help you in some way, not to I guess they give you something to focus your attention on, so you don't have to like go to a browser or a messenger or whatever. But I guess maybe that's could be inflicted somehow. Maybe when we detect that the ID detects that the person spends maybe too much time doing something, maybe the ID should offer them some other task to solve. Do you think that could be helpful or not?
That would be nice, but the behavioral science of attention difficulties, it is the very complicated question. So if person indeed distracts a lot, it doesn't necessarily will tell us that something is going on with his attention, his or her attention, but maybe it is something about their motivation or something else. And that is the behavioral science of the symptoms. It is the most important and interesting part of the future research, how we can gather such precise information from person's interaction with the IDE, and how we can pin that behavior to specific symptom or specific condition. That would be very interesting, but it requires a lot of work.
Yeah, lots of data first of all, because it was hard enough to collect these 35 people. Yeah, and there's maybe much more. We need much more data. However, about applicability of these results, first and foremost, I think that it could be interesting for user interface developers, because there is always discussion, because how to minimize our interface, how to simplify it, because it could be too complex for our users. However, we wanted to show that sometimes complexity could be beneficial from the even neurodiversity perspective, not as just navigational perspective, but it can help people just to work better. It's first result. And second, with the study, we wanted to show that actually people with different types of disorder could have some problems working with the code, and it's also important to make neurodiversity friendly IDE. So it's also important, and it's first step kind of in this direction, because there's not much of studies in this field, probably 2 or 3 done by Microsoft by one person. Yeah, so it's very small field, and we are happy to make a new step here.
Maybe in the future you can have more than just Zen mode for everyone, but like a special button. If you have attention difficulties, you can switch to more neurodivergent friendly interface that help you work. But yeah, as you said, the study about how we can detect attention difficulties via the data collected by IDE, it's a big, interesting, but different study from the one we have here.
Yeah, that's for sure.
Yeah. Actually, we studied this. We started this study. All right, I will tell for myself. I was sure that the mode will help people with attention difficulties. So, and in the end, it was just vice versa. Yeah.
I was thinking the opposite.
Did you have a bet?
No.
He has a bet with Yaroslav.
Yeah,
so
that I know. Yeah,
one of the psychological studies. Yeah,
against Sergey. Yeah. All right. So So I guess getting back to this point of understanding what's going on, maybe some eye tracking hardware would be useful.
Yes, I'm thinking a lot right now about it. So I believe that, for example, if we could combine the stream of data that we already have from the IDE, from the task tracker version, current version, and we'll enrich it with the eye tracking, it could be a very significant research tool. However, there's a few problems. First of all, for eye tracking experiments, we need to study people kind of in person, and currently it's a problem. However, we can try to estimate eye movement with web camera, and it requires a lot of development. But yes, we are thinking a lot about it, because in the study it feels that we left some part of data because of this. So I was talking twice as 3 times because we need this data. Yeah.
Yeah, but nowadays it's much easier to travel, and people are getting back offline. So I think that we might be able to find some people. Yeah, right. Nasty, you're next. But while you're asking your question, please look at the chat. There's a question there as well. Nasty?
Okay, yeah. Hi, thank you for this presentation. I have a question about the debugging process, because as I remember correctly, you consider only you asked user to find some typos in code and something like this, and it's not real debugging process. I mean, in IDE, for example, you can find all these mistakes automatically by the and the real debugging process should requires more concentration from you, and do you consider some possibility to change this experiment and to consider more real world debugging? I mean, yeah.
Yes, I will give you So,
Okay, thanks.
Agnia.
The main point was not in debugging per se. It was about monotonous task. Yes, when you did that task, you definitely was in some kind of monotonous state. And we are talking about the help of this IDE change, mode change to high perceptual load when your task not is debugging itself, but monotonous. If you find yourself that coding in some point of your time making you monotonous, routinous, yes, you can change to that type of more vivid IDE, and that would help. So you're right, you're totally right that our circumstances, our tasks were not as close to real world as we wanted to, but we wanted to make it monotonous. We did it, and we report that in monotonous task it would be beneficial. So that is the trick. But you are totally right about the task. It would be nice if we could use like real world data from people, as Serheyuk maybe will or already told you about the idea of making people agree to for us to gather all they're doing inside their usual work in IDE. It would be really helpful, and that might be a trick to gather data and analyze it in the terms of you are telling us about real world.
Okay, because the debugging process, you have a lot of additional buttons and panels, and probably I'm not sure that we can create something like Zen mode for debugging process, because it requires a lot of information, your console, your variables, different variables. Yeah, and it would be interesting question: how can we optimize the debugging process for people with this kind of diseases? Yeah, it sounds like great future work.
Yeah. Yeah, Nastya, you also have comment on this question?
Yeah, I want to add that I agree about that's not a real task when you find the typos, but this task was chosen because we was trying to find a task that is not affected by how professional you are, because you know how you debug, what code you write, it's hardly depends on what type of programmer are you, what programs are you using, etc. And we wanted to find monotonous tasks that would be monotonous for all, and at the same time equally simple or not simple for everyone. So that's another problem with the real life tasks, because if it's a real life tasks, they are very different in different people. But we'll think about creating a more real life tasks.
Yeah,
sure.
But I think in your research also the English level of participants can affect to this debugging process, because Python it's like natural English language. Yeah, and probably it can affect. But
we were trying to find typos that were like in a simple words, and it's definitely a typo. You know, I promise you, there was no such complex words that in this presentation.
Yeah, so all typos was handcrafted and discussed. Most of them was discussed. So if they are equally obvious, there was a few kind of typos and stylistic bugs which was kind of not very good and was hard to detect. However, everything else we think was good enough. And lastly, I wanted to notice that sometimes, even with all highlighting, finding typo as a source of your bug is still a case. So I think there is some small grain of truth inside of this task. Yeah.
Yeah, thank you.
Yeah. So
regarding the title of this task, I think you could do is just like quote debugging and say like,
yeah,
we call like label code name debugging.
Yeah, and also coding.
Not to provoke anyone.
Yeah, we have question from the chat. Agnia, probably you have better view
Yeah,
on this.
we indeed had a lot of work about research of previous research. The most helpful were several of them. Two specifically showed that in different, not real world, as you saw on slide with SpongeBob, on some task, people with different level of severity of the disease go better with that tasks if the perceptual load is high. So that was the most important inspiration for us. Also, we had some research about adaptation of people with ADHD in their work environment. That was Sergey mentioned about Microsoft research. It was case studies, several of them in one paper. And I guess that were the main inspirations for us. So the idea that in IT world it is important to help people to adapt, neurodiverse people to adapt in that circumstances, and that we can do this by changing the perceptual mode. That it was to inspirations.
Yeah, also we looked at a few papers with ergonomic study, because they are studying how actually interfaces affect. So in different industry settings, for example, there's a lot of actually works about how jet fighters working and how to optimize the interface for jet fighters. Yeah, and the cognitive load of these interfaces. So yeah, we also looked in this direction too. Yeah. So Nastya?
Yes, I wanted to add that this research is, such researchers are usually concentrating on finding the tasks that good at measuring attention, as you've seen on the picture, like find the letter or find the right picture, etc. But they're not much like real world tasks, and there is quite a few researchers about how this attention works in real life, and we wanted to why are you laughing?
Because none we were found about real world.
Yes,
Yeah.
I said not much because maybe we overlooked something, but yes, we haven't found any researches about coding, and we thought, wow, coding is such an attention craving tasks, and maybe we can create something about code.
Great. Thanks so much. Yeah, sorry, I'm in a noisy environment, so I typed.
Yeah, cool. So you can ask her in any way it's okay for you. So any other questions?
Have anyone tried to put a programmer into an fMRI machine while they're programming?
Yes, there's not fMRI machine, but there was a study when how it actually was. So they measured blood pressure in the brain, something like this. I don't know exactly how this machine actually works, but they measured amount of oxygen and blood pressure in the brain during solving while solving programmer task. But to be honest, it is good study from perspective of neuropsychology, because they have correct analysis and so on. However, they asked to solve problems in Java, and only 3 people in the sample knew Java. So there was some kind of a methodological problems with programming part in this study. However, yes, there's a few studies where people try to use different neuropsychological approaches while coding. However,
There is the same
yeah.
problem. There's lots of researchers, lots of studies when you put someone in the fMRI and ask them to solve some tasks, but usually the tasks are not very life related.
We should
Yeah.
buy this machine, I guess.
Yeah.
Yes,
Well, let's
please.
start from the cracking.
Yeah. And our team building sessions would be very different from that point.
Yeah.
Okay, then. Any more questions? Okay, I don't see anyone. So then thank you guys for this wonderful talk. It was very interesting to listen to. If anyone has any questions or anyone listening to this recording has any questions, please feel free to contact us in any way. And I'll see you soon. After the New Year's, please come to our seminars. Yeah. Okay,
Bye.
so bye everyone.
Bye-bye.
Happy New
Thank you.
Year.
Bye-bye.
Bye.